Good morning all of you. Today we are going to discuss about the product life cycle.
Do you have any doubts in whatever we have discussed earlier? Were you able to understand the manufacturing process of a product? So can somebody briefly tell me how it is being done? At least the essential steps. Yes? Yes? What is the raw material for that? Because, see, I want you people to develop a skill for details. What is the type of food that is being used? Why? Very good. I'm very happy to learn so many people saying Cedar, but why?
Quality.
Is it lightweight? Will you mind if your pencil weighs 10 grams more?
Lightweight. Quality.
What quality do you expect?
Will not be
Any wood will hold the graphite inside. Is it not?
Soft.
Why should it be soft? Because subsequently, not just lightweight, because subsequently I am going to sharpen it. If it is a very hard wood, I may require special tools to sharpen my pencil. I want my pencil to be sharpened with simple tools like a knife or a sharpener. Okay, fine. Then you take Cedar. So, please, see what we are trying to do. We are going to discuss, that is the first year that we took up. Subsequently, every day we will be discussing one product. Okay, every day we will be discussing one product and how that product is designed. That is what we are going to do. Now, what I want you to learn is, you develop a knack of analyzing a product design. Why a material is selected, why a particular choice of manufacturing process is made, okay, why a particular component exists, what it does in the overall system. So, I mean, the pencil making process, it can be analyzed at any level of detail. Probably, if you let me, I will talk for 1 hour about it, you'll get bored. So I'll leave that. All that I'm trying to communicate is, you try to understand more and more. Question everything. Okay. And you should be able to give a logical explanation for the various details of the particular manufacturing process. Okay. Let us go to today's lecture. Any doubts you have, please feel free to ask whatever doubts you would like to raise. Anything, let it be trivial, let it be silly, I don't mind. Let me be the judge. Any doubts? Okay, then we'll proceed to today's lecture. Today we are going to discuss about what is known as product life cycle. Every product, it has something called the life cycle. Like a human being has a life cycle. You come into this world, you become a living organism. Then slowly you grow, you mature, you saturate. After that you deteriorate, you die. True for every individual. Okay. So like that, a product also, it has its own life cycle. See, what today we are going to have understood what a product is. Today we are going to study the life cycle of a product. Because ultimately we are going to be the creators of products. We are going to be designers. So I should understand the various facets of a product, the various stages of its life cycle comprehensively. So then only I will be able to do my design properly. So I am not going to take up a life cycle of a particular this product or that product. Okay. We are going to discuss the generic life cycle of a product. Okay, whenever I talk about product life cycle, I cannot forget my neighbor. Okay, my neighbor used to make quarrels at times with a paper bar. Okay, he has a very meaningful statement. I don't know whether he would have uttered it many times. He will tell the paper bar. He will tell in Tamil, but for the benefit of everybody, I will tell in English. Only if you deliver the paper at 6 o'clock, it is a newspaper. If you bring it at 8 o'clock, it is a waste paper. That is what he will say. Okay. Paper நீங்க 6 மணிக்கு கொண்டு வந்தா அது நியூஸ் பேப்பர். 8 மணிக்கு பேப்பர் கொண்டு வந்தீங்கன்னா அது வேஸ்ட் பேப்பர். What is the meaning? What is the difference between, what is the relevance of this? Is it just a joke or does it have something to do with what we are discussing?
It should be marketed at the right time.
No, the product life cycle of a newspaper is when does the newspaper coming to be? When is it born? Can somebody say? Early morning? Or will you consider only printing and then coming out of the process a birth of a newspaper? The intellectual birth starts much before, is it not? Somebody has to write all the matters. So shall we take that as a birth of a paper? The editor has to decide what are all the items that are to appear. Okay. So, roughly, can you fix up a time when a newspaper is getting seeded? I mean, the seeds are, when it starts giving birth. It doesn't take place at a single instant. Okay, starts let's say 6 o'clock in the evening. Okay, all the news pouring from different places. The editor decides what are all the items that are to appear. That is the time instant at which its life cycle starts. Accepted? The life cycle of a newspaper starts roughly at 6 o'clock in the evening. News from different parts, they pour in. The editor decides what are all the articles to appear. Then he asks the sub-editors to pen down or key down the articles. Alignment, layout, all this process takes place. Printing gets completed roughly about 2 o'clock in the night. Okay. Then transportation of the papers to various parts. Okay. I think it is a correct news only. The first people to own an aircraft, first company to own an aircraft in Tamil Nadu, okay, I think it is either Hindu or Indian Express. The first corporate to own an aircraft. The reason is they want to very quickly transport the newspapers. Okay, I am not very sure about the detail. I don't know whether I am getting slightly mixed up. But the essence of the matter is you need to transport it quickly to different parts. They must be made available in the stands. They must be made available at your doorstep. So, I would again try to. Then the reader takes it up. Okay, he goes through. After 8 o'clock, I mean, my utility of the newspaper that I buy is over by 9 o'clock. After 9 o'clock, I don't have any time to go through the newspaper. Okay, it is a waste paper. Okay, probably for my neighbor, if he doesn't get a newspaper by 6 o'clock, he will switch on the TV and get all the news. So after 8 o'clock, he knows everything that is there, almost everything that is there. So he considers it as a waste paper. So now it starts, the light starts at 6 o'clock in the evening and then it ends by 8 o'clock and 9 o'clock in the morning. The effective lifespan of a newspaper is how much? 14-15 hours? Roughly 14-15 hours. Now this is called the product life cycle. A newspaper has a product life cycle of roughly 14 hours, 15 hours. Right from its birth to, of course, you cannot, for all practical purposes it is done, but it has to be recycled many times. In today's world, we are bothered about the sustainability, all the environmental issues. So in the life cycle, we introduced what we do after the death of the product. Even that is included into the life cycle. So slightly it may extend the other side, but the effective life cycle is over in 14-15 hours. Now what I want to do is, I want to segment this life cycle into different regions, different processes, because I want to understand it better. Now can I say from 6 o'clock in the evening to 12 o'clock, before it goes to the press, what are the activities that are taking place? Can somebody list? What are the activities? Gathering of information, then editing, deciding what to publish, what not to publish, writing it,
Printing.
roughly laying out, not printing, till 12 o'clock I said. Laying it up, putting figures, photos at appropriate places,
Be the headlines.
decide what should be the, deciding the headlines, deciding what should be in the first page, what should be in the second page, what should be in the 14th page, what should be in the laying out, everything. Can we say, can you give a generic name for this phase, for this part of the life?
Design.
It is the design phase of a newspaper. Okay. Deciding the content, deciding the style, okay, everything. This is the designing phase of a newspaper. Now let us take 12 to 3. 12 to 3, what is happening? Printing, cutting, folding. Can you give a name for this? You said it. So the second phase is the manufacturing stage. Now let us take, say, 3 to 6. What is happening? Transportation. Going there, the agent must be fixed. Okay, the vehicles must be hired. A paper bag must be arranged to take it to the doorstep. Okay, there must be a huge distribution network established. What would you call this stage as? Transportation. Okay, delivery system. Okay. Then 6 to 8 is the actual. The reader is reading it. What is that? The product is being used. It is being made use of. The product is being consumed. It is operated. Okay. Then what should be? What shall I call the last phase? It is recycling. Okay. I sell it to my waste paper wala. He takes it, makes it into a pulp, okay, then he makes paper again or he does something else with it. Okay. So, these are the different stages of the life cycle of a newspaper. Is it okay? Now what I want you to do is, let us get away from my neighbor and newspaper. Let us see what the general life cycle of a product consists of. Can we have the first slide, please? Now the product life cycle consists of, okay, can I go back to the next slide and then we'll probably come back here. Okay, we'll go back and forth with these two slides. The first stage is design. The second stage is manufacturing. Okay. The third stage is market operate. Market means the marketing of the product, distributing it, operating it. That is the effective usage. The fourth part is the recycling. So the life cycle, I have divided the entire life cycle of the product into 4 stages. One is design. The second one is manufacturing. The third one is marketing, operating. The fourth one is testing. And depending on the specific product, we can segregate market and operate. In many instances, they can be merged. Okay. It all depends on how you view the whole thing. Let's go back and then see the design phase in detail, the manufacturing phase in detail, the marketing and operating phase in detail, and then the recycling phase in detail. Now, if you take the design phase, the life of a product, it starts. The first thing that we must keep in mind is, it all originates from a societal need. You should never forget that. The first principle that we have identified, the first role we said a product must fulfill is satisfying certain societal needs. So product, essentially, it has to satisfy from a societal need. So first I must identify what is the need that my product is going to fulfill. There is a vacuum, there is an empty space that needs to be filled. People need to know the news. Okay, what happened all over the world yesterday, I am curious to know. I am not insensitive to my surroundings. I am just curious what happens around me. So that is the need that my newspaper it tries to fulfill as a product. So please note, unless the product attempts to satisfy a societal need, it doesn't have a locus standi. It cannot exist. So that is the starting point. Then you plan for a design process. Having identified the need, you plan for a design process. Is it okay? You plan a sequence of operations that will lead to the design of the particular product. So you have to plan for the design process. Now you have to develop engineering specifications. Of course, I'll be discussing these steps in detail later. But all that I'm trying to impress upon you right now is, design is not a single activity. It consists of many sub-activities. One is identifying the need. But please note, one of the biggest challenges for organizations is, the needs of the people, it doesn't manifest itself, okay, very obviously. What do I mean by this? The needs of the people, it doesn't manifest itself very obviously. Now I don't know, if 10 years back, okay, will there be somebody who said, I need a device which will help me to communicate. This new device must be mobile. I should be able to use internet in it. I should be able to view videos in it. I must be able to take photographs with it. I must be able to send text messages either in short form or in long form to anybody around the globe. I should be able to have the local map of any region all over the world. I should have connectivity with GPS. Is there anybody who would have identified all these needs and said, I need a product like this? I mean, the cell phone that you have has all these functions. It has GPS. You can take pictures. You can communicate. You can talk. You can send text messages. Okay, what not? You can use internet in it. But will some customer stand up and list out what are the factors that he expects? What are the characteristics that he expects from a cell phone? No. So many times the needs, they are not so explicit. So the needs are to be identified. I should, as a corporation, I should be able to identify that if I attempt to satisfy this particular need, it will click. Then I should from the customer, somehow I should get what the customer really wants. What are his expectations? Then I should convert that into engineering specifications. The customer will not stand up and say, I want a gallium nitride enabled CMOS technology so that the packing can be very dense and my device will be very small. What is said right now is an engineering specification. Where you want all your ICs to be very small, which means the technology and appropriate technology relevant to that must be clinched. All that the customer will say is, I want my cell phone to be very light. So I want it to be very compact. This is how a customer will say. But that has to be converted into an engineering specification. Of course, we will go into the details of this later. So I have to develop engineering specifications. Then I have to develop concept. Engineering specification is a wish list. I want to achieve this. I want to achieve this. I want to achieve this. But how to achieve this? What is the technology through which you will achieve this? So you need to develop a new technological concept to deliver what the customer wants. For example, take the case of a two-wheeler. When you want a two-wheeler, what are the things that you look for? Can you please say, what are the things, your good name please? What are the things you look for, the person before you? Yes. What are the things you look for when you buy a two-wheeler? What do you mean by CC? No, my CC is an abbreviation. If so, what is that abbreviation? What will be approaches? Yes. Cubic capacity. Is it? Is there any unit like cubic capacity? Yes, cubic centimeter. So, CC is cubic centimeter. Cubic centimeter is a unit of what? Displacement unit is centimeter. Please, see, I want you to develop precision in your talking. How can I say cubic centimeter is a unit of displacement? Displacement unit is what? Centimeter, meter. Okay. So cubic centimeter is a unit of volume. Fine. So what volume are we talking about? Okay, the displacement volume of an engine. That is, when the piston of an engine makes a stroke, the volume generated, then it is a cylinder, isn't it? You have a circular cross section, the piston is here, and then the piston makes one complete stroke. So I get a cylindrical volume. That volume of the cylinder is referred to as 50 cc, 100 cc, 1000 cc. So the volume of the engine cylinder is specified as cc, cubic centimeter. But somebody said it talks about engine power. What does cc has to do with engine power? Is it related or not at all related? Then how? How fast? No, you are confusing issues. My question is simple and straight. I have said right now cc means volume. And what is that volume in the context of a cylinder? Volume made by the stroke. Clear? That's it. Relate in any way to the engine power. Yes? Engines? How? Why should the engine's power be related to the stroke? See, that specifies the maximum amount of air. That specifies the maximum amount of air that a piston can take in one stroke. So naturally, only fuel that is sufficient for this particular air can be burned. If I even pour in excess fuel, what will happen? It will go back as unburned fuel. I am taking so much of air only. Now that puts a limitation on the amount of fuel that can come inside. Are you getting my point? Now the stroke determines the volume. That determines in turn the amount of air that can be sucked in. Now the amount of air sucked in is freeze now. That means if you want coupling conversion to take place, we can take only so much of fuel in. If we take much more, what will happen? It will go as unburned fuel. So this is indirectly related to the power that can be developed by the engine. Okay, right. When you buy your two-wheeler, you are looking for the power that my engine can deliver. One criteria. Then mileage. Okay. So you want to have a fuel efficient engine that can deliver good mileage. Fine. What else? Hey, please talk like a youth. Believe me, your father, if he tells that he wants mileage, I can understand. Yes, what do you want? Okay. He said it. He wants speed. Will you just want speed or will you want something else? Yes? No, I can hear you. You need not shout. Tell me, what is it? Okay. So, you want pickup. So, what is this pickup? It is the maximum speed. How do they specify the pickup? In advertisements, how do they specify the pickup? 0 to 100 kilometers per hour in 10 seconds. So what does it mean? What is the engineering meaning of this? I can achieve 0 to 100 kilometers per hour in a particular period of time. Now 100 meters per hour is a velocity, is it not? 0 to 100 meters per hour in 10 seconds is acceleration. That is how acceleration is popularly represented. My engine is capable of, if they say my engine is capable of accelerating at 10 meters per second square, nobody will understand that. So the popular way of expressing the acceleration is so many 0 to 100 kilometers per hour in so many seconds. So essentially the customer says, I want good pickup. What he meant is, he wants a very good acceleration. What the designer must first do is, convert this voice of the customer. Voice of the customer, what is the voice of the customer? What did he say? Good pickup. Not even acceleration. Good pickup. This voice of the customer is to be converted into so many meters per second square of acceleration. My vehicle is capable of delivering so many meters per second square acceleration. That is the engineering specification. Now, how do I achieve this? So, this is only a wish list. Engineering specification is only a wish list. I want to achieve such and such thing. I want to achieve so much of acceleration. I want to achieve so much of fuel efficiency. I want to achieve so much of power. These are all the wish list. How do you convert it into a reality? So what you do is, you develop various concepts that can meet these engineering specifications. What do you mean by concept? How do I increase my pickup? How do I increase my pickup? Your engineering mechanics will teach you the subject that you are studying. Engineering mechanics will teach you, if you want a large pickup, the inertia of the system must be low. When you want the system to be very agile, you want to have a very good pickup. Be it an automobile or be it anything. Okay, if you want to perform very well in sprinting, okay, probably your weight has to come down. It cannot be a good sprinter. He cannot have more than excess baggage on his body. Okay, his body must be very agile. It should be well groomed. So the inertia of the system must be brought down. So I must develop. Say I must try for weight reduction. How do I try for weight reduction? So what we are trying to do here is, say instead of using metallic parts, try to go for composite parts or plastic parts. This is one approach to. See what I'm trying to show before you is, you have a voice of a customer, that was converted into engineering specifications, okay, and you develop that into the various, you try to address these specifications using various concepts, incorporating various concepts, okay, you develop a product. You understand? By combining various concepts for achieving various things. For achieving a particular BHP is breakout flow, I should develop something. Okay. To develop a particular acceleration, I should devise something else. Okay. To achieve mileage, there may be at times be conflicting demands. People want at the same time very high pickup, high power, at the same time good fuel efficiency. So there will be, you have to do a sort of compromise, and then you develop the product. So developing a product usually it culminates in developing detailed drawing for the entire system. For most of the mechanical parts, for most of the mechanical and electromechanical systems, developing a product, it culminates in arriving at a detailed drawing for the entire product. Then you have to, this is the first phase that we talked about. Can we go back? So the design phase is over. Now comes the issue of manufacturing. In the manufacturing phase, okay, can we please go back? Now in manufacturing, first of all, even before we venture into manufacturing, we discussed in the previous class itself, design is of no use if it is just designed for design's sake. Design logically must lead to manufacturing. Anything that you design, it must be realized as a product. So designer must also, that is the real challenge behind the design process. That is the challenge before the design process. There are many things that are expected from a designer. So designer must know what are all the various manufacturing processes, whether this particular product or component or a subsystem, whether it could be realized through the existing technologies. So that aspect must be brought into the design stage itself. So you manufacture components, you assemble them, you distribute, you install at the customer's place. So these are all the various. The second part is the various stages involved in manufacturing. Then you have the user who is going to operate it many times. Then it should be maintained. It should be repaired whenever there is a problem. You have to clean it, you have to maintain it. When something goes wrong, you have to set it right. Then in today's context, since sustainability issues are becoming prominent, environmental issues are becoming prominent, people are worried about what after the life of the product. What are we going to do once the useful life is over. So how we are going to retire a product? That is of concern today. Even in India, we have the manufacturer is made responsible for complete recycling of products in certain segments, like batteries, lead-acid batteries. The manufacturers are responsible for recycling. It is likely to. In Europe and US, the manufacturer is responsible for even recycling of many products, including automobiles. So you have to have a plan how you are going to retire a product, how you are going to dismantle it, and how it is going to be recycled or reused. So this is the complete life cycle of a product. Now can we go back again? Thank you. One minute. Sorry. Now, in today's world, the product life cycle has certain specific characteristics. Unless we understand these specific characteristics of modern product life cycles, we cannot really do justice in our design job. Now, what are these specific characteristics? What? The cycle time has shrunk. What do you mean by cycle time? Can you tell me what do you mean? What do I mean by the cycle time of a product life cycle? Yes? Huh? From which point to which point? Is it period of using? No, we have to be very careful. We have to be very specific in understanding. Is this the life cycle of a product that we are talking about? That is the useful life of a product. You say, I buy a two-wheeler, use it for 5 years. Is that what we talk as product life cycle? No. Okay. A particular model of two-wheeler has come into market. Do you understand? That particular concept, it got originated at a particular point in the time frame. Then that particular product, that particular model itself has become redundant after a particular point of time. Do you understand? This entire time span, I call it as a product life cycle. Okay, I gave you the example of a product life cycle of a newspaper. When is the birth time? Evening? 6 o'clock. Okay. When does its life end? Morning? 9 o'clock. 8 o'clock. So that is what I mean by the life cycle of the product. Now, what I mean, suppose you have a particular model of an automobile coming into being. Let us take a particular model of a mobile phone coming into being. What is the latest in mobile phone? Okay? iPhone came into being. What are the characteristic features? Touch screen. Good. Android. The operating system is Android. Okay. iPhone has touch screen, Android, internet connectivity, GPS. Okay. These are all minor things. The major things we have addressed. Okay. Touch screen. Okay. Android operating system. GPS. Then. Fine. And a particular weight, a particular size. Is it okay? Now, how long do you think this particular product, this particular specification will remain in the market?
1 year. New product.
No, you make a guess. Naturally, a superior specification is going to come, and that is going to completely walk aside this.
6 months.
So your guess is, people here say it will roughly be a year or two. That is, even if you take the design phase into your reckoning, at some point of time they would have decided this is the design specification that I want to achieve from the various market surveys. So now, even if you reckon that into account, the average life cycle of a cell phone is roughly 3 years. After that, this product becomes completely redundant, obsolete. Now, what I mean by the life cycle of product coming down, the life cycle of product coming down is this. From the concept stage to the product becoming technologically irrelevant, redundant, this time frame, it got shrunk significantly. The classical example, many of you might know it, but still I cannot but say this. How long did the brand ambassador prevail in the Indian market?
So many years.
Okay.
More than 10 years.
No, not 10 years. It's more than 30, 40 years. Okay. In between ambassador Mark 1, 2 and 3, absolutely there is no significant difference. But for few cosmetic changes, ambassador Mark 1, 2 and 3, it didn't have. So from concept to even today, I cannot say that ambassador has become irrelevant. It has not become redundant, but technologically it is not a. No automobile engineer will argue for a moment that ambassador is. It has its own positive aspects, but technologically it has become. I can confidently say, though practically it might not have become redundant, technologically ambassador has become redundant. Practically you may still see that particular brand of vehicle operating on the roads. But technologically speaking, ambassador has become redundant. Okay? So it enjoyed an effective product life cycle of 50 years, 40 years. Even by conservative estimates, I can say it enjoyed a life cycle of 40 years. Well, what is the typical life cycle that you can expect for any automobile that is coming today? Maximum 3 years, 4 years. Okay, even 1 or 2 years. So, the life cycle of the modern products. Please note, this is not only true for your cell phones and automobiles, it is true for many products. All products. The effective life cycle has shrunk. So, why we should be bothered about this? I'll come to it later. First, let us understand what are all the characteristics of modern day products, because these are all the issues I have to reckon, I have to take into account when I venture to design a product. So the life cycle got shrunk. Now, not only the overall life cycle had shrunk, but also the life I would prefer to divide it into two parts. The life cycle I would prefer to divide the entire life into two parts. One is the first two phases. Whenever we discuss the product, can you repeat what are the main characteristics of a product? Satisfier? Then? Yes. A product is something meant for market. Is it okay? Why I should? Because I have to reckon have to take into consideration competitions, economics, the commercial aspects, profitability, all this. That is why whenever I think of a product, I should also keep in mind that it is for market. Now, in the entire life of the product, when does that product reach the market? Suppose say this is the timeline. This is the timeline of the product. When does it reach the market? Okay? At this point, it reaches the market once the manufacturing is over. So, the first part, I say, time to market. The time I should take to market a particular product. Then I develop a concept for a new cell phone. So that cell phone must have so many so and so specifications. I arrive at that. Now, realizing that and then putting into the market, deciding that, realizing that, putting into the market, that is the time to market. Now, if you are a CEO of a company, okay, if you are a CEO of a company, okay, say the life cycle of a whole product is 3 years. You said for typical automobiles, the life cycle is 3 years. I am the design engineer. You are the CEO. So please remember, after 3 years, the product is going to become technologically obsolete. During the time to market, will you get any profit? The product does not come out. Why is the question of profit? When I make a drawing of a product, will the company make any revenue? When I make parts for my car, will the company make any revenue? When will the revenue come? Only when I release the product, only when somebody buys it, the revenue comes. The entire life is going to be 3 years. I am the design engineer coming and asking you, please fix the time to market for me. What will you do? How much time will you give me to design, manufacture and deliver you the product? 2.5 years? 2 years? 6 months? 1 year? Do you understand? See, when the entire life of the product itself is only 3 years, as a CEO, you would like to have as small a time as possible as time to design and manufacture, both together. That's what I mean by next slide. Next slide. Steeper reduction in time to market. So if the life reduces by say 10%, okay, my CEO will reduce my time to design by 50%. Because this is, the time to market is a period of no revenue, only expenditure. So that any organization would like to have as small as possible. The next point is, this puts enormous pressures on designers. Okay. The entire useful life of the product is going to be very small, and the time I am given to deliver the product is much more smaller. So I must do my job really fast. So a lot of tools, new tools have emerged, okay, like computer-aided design, computer-aided manufacturing, computer-aided engineering, rapid prototyping. Of course, we will see all these in details. Now, all that I want you to understand is, what is the product life cycle and what is the characteristics of today's products, okay, with regard to the product. Next slide. This is a very interesting slide. Okay. Now in the x-axis you have time. In the y-axis you have the percentage of cost that is committed. Y-axis simply you take it as a cost. Because y-axis has two meanings. One is cost incurred, the other one is cost committed. What is the difference between the two? See, this is the you have the specifications developed, okay, probably I'll use the pointer there. This is the first phase in which the specification is. This is the phase in which the specification is developed. This is the phase wherein the conceptual design is developed. Then the entire product design is done during the surface. So at this point of time, I have the detailed drawing of the product. Is that understood? Now when I arrive at, so this is the cost incurred in designing itself. This is the cost incurred in the designing itself. This is the cost that I commit by making a design decision. Okay, by making a particular design decision, I commit to spend so much at manufacturing. At the end of the detailed design, I cannot have much of cost control because all my detailed designs are over. I have decided my material, I have decided my manufacturing process. How can I save the cost? So, at the end of the design, at the end of the design phase, at the end of the detailed design, the cost that I am going to incur while manufacturing is frozen, it is committed. So, suppose whether to use a decision to choose between two materials. See, suppose for a particular component, I want to make a decision of using either a low carbon steel or stainless steel. What difference does it make? Low carbon steel may have a life of 3 years when I use it. When I use a stainless steel, the life might be 6 years. During the design phase, I am supposed to take a decision regarding this. I should specify what material I must make, what material I should use for making this particular component. So when I say it is stainless steel, the cost is going to be 10 times more. The cost of low carbon steel, for your information, is around, in today's market, it is 40 rupees per kg. On the other hand, the cost of stainless steel is around 340 or 360 rupees per kg. Okay. So when I make a decision about the material choice, I do make a commitment. Now, at the early stages itself, at the end of the design itself, the total cost of the product is getting committed. Why I am showing this slide is, a designer must be very responsible. There cannot be any cost reduction once the design is over, because all the major decisions are already checked, already over. Next slide please. Of course, this is the basic paradox in design, and this is the basic paradox in life also. Okay. Now in the x-axis again you have the time into design process. When I enter into the design process, I don't know anything. When I enter into the design process, when I start my design process, all the design engineers, they are not masters of that particular domain. So they have to learn. They have to only learn. So initially, the percentage will not be zero, but initially, they start with a low knowledge level. And this is their learning curve. They slowly gather the knowledge. But what is the freedom that I have? Initially, I have not committed anything. I have not made any decision. So I have a large amount of freedom. I can either do it this way or that way. But as I proceed further, my design freedom is lost. There are so many constraints. So the basic paradox is, with very little knowledge, I am taking more important decisions. When you have freedom, you take decisions at this point of time. Okay, these decisions are taken with very little knowledge. At the later stages, I don't have any constraints. I don't have any freedom. I have a lot of constraints. So at that point of time, so what is the message from this? The message from this is, right from the day one itself, I should try to make my learning curve as steep as possible. Then only I will be able to take some informed decisions at the early stage itself. The slope of the learning curve at the early stages, if you could really make that steep, you will really succeed in your design. And this is true in our day-to-day life also. Okay, I mean, we have started a semester. Okay, you have a lot of freedom now. You don't have any tests right now. You don't have, your knowledge level in various subjects is also relatively, you're starting this semester. You have a lot of freedom. You can, if you decide, you can go to the cinema. You can watch TV for 3 hours, 4 hours, or 5 hours, or 6 hours. You can keep on chatting, do whatever you want. But you have freedom, but still, if your learning curve is not steep at this stage, all the decisions that you take might lead to be very costly, very expensive. Next slide, please. Now I want you to answer this question. If you have two companies, please try to understand. I'll explain what is the x-axis, what is the y-axis. This is the point at which the design began. This is the point at which the design activity started. Okay, for company B, this is the point at which it started. Now, in the y-axis, I have number of design changes. They started the design. Okay, the number of design changes were, it slowly increased and then it reduced. After some point of time, you have to freeze up things, you have to firm up things. So the number of design changes, they got reduced. And this is company B. Company A, you had the number of design changes in the early time itself is very high, and then the number of changes got reduced. Which do you think is a better situation? Why? No, can you talk with some mathematics? I have shown you two distributions. Whenever I say distributions, what are the things that strike you immediately?
Probability.
No? What are the parameters that characterize the distributions? How do you measure? Engineers always want numbers. How do you measure? No. Any distribution can be characterized by its mean and standard deviation. Okay. What do you mean by mean? Okay, average. It is a measure of dash. Mean is a measure of dash. Mean and standard deviation are altogether different things. Mean is a measure of the central tendency of a distribution. How the whole thing averages to be, that is reflected in mean. See, whenever we talk about some characteristics, you should have a feel for it. You should try to understand what it means. Mean means, suppose there are 200 students in this class. What is the mean mark of this particular class? What does it convey? Average. What is the if I have to give a single value as a performance of this particular class, mean will tell that single value. So mean is a measure of central tendency. Now the opposite to that, I mean another altogether different, if not opposite, another altogether different parameter is a measure of dispersion. Is there large variation in this class or the variation is small? I want to know. Whether in my class I have very bright students and very poor performing students, or almost all of them are average. This info I want, this particular information I want. I have to look at. Can you give me a single number? See, don't give me all the 200 marks. I don't want that. I want the overall performance of the class. What number will you give me? Average. Mean. I want to know whether I have students and very poor performing students, or almost all of them are around the average. I want this particular statistic. Which parameter will you tell? You can tell the range. Range simply, first you should say range. Maximum mark minus minimum mark. That gives me an idea whether I have very intelligent students and very poor performing students, or all of them are close to the average. So range has a limitation. A better measure of this is standard deviation. Now if you see company A, it makes okay, most of the changes at the early stage itself. Company A made most of the changes at the early stage itself. So that is one advantage for company A. Then the life cycle of company A is short. On both counts, the performance of the company A is better. At the early stage, if you make a lot of changes made in the early stage are always better rather than changes made at the late stages. Okay, you finalize everything. See, changes made at later stages might be very expensive. So you might have heard about many cases. Okay, product recalls. This is the nightmare of a product engineer. What do you mean by product recalls? No, still worse. Have you heard about product recalls in cell phones? Recently Nokia said that if the numbers are, if the product serial number is between this and this, you can bring the cell phone to the service center, and then get your batteries replaced. Have you heard about it? It is a nightmare of a, because the battery design it was a faulty design. There were battery explosions. Okay, imagine what will happen. You are hearing to your friend and suddenly the battery explodes. There are battery explosions in Delhi. Okay. When they analyzed that particular failure, they said that this is due to a faulty battery. So the entire batch of products made during a particular period of time, it has to be completely recalled. So this is a change made at a later stage. But at the design stage itself, if they have diagnosed this problem, this would have saved millions of rupees for the organization. So early changes are better, okay, and the smaller time to market is better. Next slide, please. Now, all that I have tried to communicate today is the idea of a product life cycle. Okay, what are the different stages of a product life cycle? Okay, so that you have seen. And what is, in terms of product life cycle, what are the characteristics of modern day products? Any doubts you have in this? Any doubts? Yes? You want to ask something? No. You can feel free to ask. Right. In which case, I got the second part of today's lecture. It is again a case study on product design. So, in the last class, what is the product that we discussed? Fine. Today, let us take the case of a bicycle. In every lecture, I am planning to introduce this case discussion. Okay. Let us see. This will help you to understand. The objective, as I told, is twofold. One is to understand the product design concept better. That is number one. Number two, by elaborately discussing various products, we try to understand the real breadth of mechanical engineering. How the various subjects that you are going to study is going to help you as a product design. Considering design as a central activity. Next slide, please. So you have various, bicycle is relatively, all of you would have seen, okay. In the initial stages, I would like to take a well-known component because then you can relate with the component. There is nothing new in the component, probably, I don't know. Let us say at the end of the lecture, okay, whether there is nothing new or we have to really re-look into the bicycle. Because I consider bicycle as a very classical piece of mechanical engineering. It has many subsystems. You have, can you go back to the next slide? You have a basic frame. This is the basic frame of a bicycle. Okay. That is the structural member. So it connects, it is the basic skeleton on which you put everything together. So all load sharing, load distribution has to be done by the structure. So the first one is the frame of a bicycle. Then you have, there must be a powertrain. So basically, bicycle is to commute from one place to another. It is, what is the source of power in a bicycle? It is the muscular power. The muscular power of the human being, the muscle power of the human being is the primary source. But the power must be delivered to the bicycle at a particular point and then it must be transmitted. Okay? See, if I punch a bicycle, it will not, I will not have a ride. The bicycle will only fall. So I should deliver the power at a designated point and that should be properly transmitted. So you have a power train. So the power train is, so we don't use the term power train. It starts from the pedal, then you have a set of gears, then it goes to the wheel. Then you have a chain. Okay. After that you have a suspension system because I don't want my ride to be very jumpy, so I want the vibrations to be minimized, so I have a suspension system. Then I should be able to steer. So there must be a handlebar and a steering system. Then I must be able to stop, so I should have a braking system. Apart from this, there can be many accessories. You need a seat, you need some cosmetic things, you need a back seat. There can be many accessories. Next slide, please. Now, can you please go back? So, frame, power transmission, wheels, suspension, braking, steering and accessories, these are the important parts. Now, complete analysis of bicycle will take a lot of time. Okay. So, I am going to take some 3-4 parts or subsystems and then I am going to study. Okay. I will take up only 3. One is, I don't know whether I have another 20-25 minutes probably. 3 or 2 I will take and then we will discuss that in detail. Next slide. Right. First, chain. What is the purpose of the chain?
For connecting.
Power transmission. Okay. The power transmission from the pedal to the wheel. Okay. Is through chain. I will not discuss chain in detail. Okay, I will just show you the slides. These are the various parts. The beauty of chain is, it is a flexible power transmission element. Chain has, can you go back to the next slide please. So it is a chain assembly is a flexible assembly. So it can have free rotation at these points. When you go back, you have what is this technically called a roller chain. In fact, you'll be studying about this later. So these are the various parts. You can see 2 rollers there. Okay. One of the, I want to just say one particular aspect of engineering design here and then quickly go to the next part. One of the, you'll not be able to understand it fully now, probably after 6 months you'll have better appreciation of this. See, unless it is essential, you don't constrain any motion. In mechanical engineering, when you design systems, unless it is very essential, you don't constraint. So, when you see, I used to, this is the example I often repeat. Okay, I hold your hand and then pull you towards me. If you just come along the direction of pull, will you feel any pain in your hand? Because the motion is not constrained. I am pulling you, you just walk along with me. On the other hand, the motion is restricted. I pull you, but you try to resist. Then what happens? All the stress they come. So in mechanical engineering also, when you design something, unless you constrain the particular motion, stresses in certain directions will not develop. Chain is a beautiful mechanical element which permits rotation at all the joints. At every joint, can you go back 2, 3? Yes, one more. Back. No. Yes. In all the joints, we have these rollers. Okay. That provides, as a basic design concept, okay, that provides a lot of capability to the chain. You look into it, how the flexibility at the roller points gives chain additional strength. You gave it certain freedom, isn't it? You permit it to rotate. That freedom, how does it help you in turn? You can explore and then probably come back to me. So I leave chain at this stage. So these are the sprockets, set of sprockets. Okay, when you want to, by the way, why do you want to change the speed of a bicycle? Yes. So depending on the torque that you need to develop at the wheels, see, the power that you can deliver is constant. I'm capable of delivering certain power to the pedals. Okay. Power, mechanical power is product of speed and torque. Electrical power is a product of, can somebody say what it is? Electrical power is a product of voltage and current. So electrical power is voltage and current. Mechanical power is torque and speed. Mechanical power is a product of torque and speed. Can somebody say what is hydraulic power? Pressure, good, and no. Volume, not just volume.
Density.
No. No. Yes. It is a product of hydraulic power development. Is a product of pressure and velocity. The power manifests in two different forms. Okay. The power is a combination. Only when they come together, the power is delivered. Another beautiful idea. Only when they come together, the power is delivered. Only when you have voltage and current, then only you have the power delivered. Please remember, it is a product. If any one of that is zero, the entire power delivered is zero. So only when they synchronize positively, the power is there. Okay. Now, the power that can be delivered by human being is constant. It's fixed. It may vary from person to person, but it's fixed. So at times, if you require higher torque, suppose you are going up slope, then you may have to reduce the speed. Okay. Or if you are going downhill, you may increase the speed. Okay. Or you are attaining a certain speed. Now the inertia is not an issue. At that point, probably initially when starting, inertia is a big issue. I have to overcome that. So you start with high torque, low speed, and then after attaining a particular speed, you can. So this is the basic idea behind gears, be it in bicycle or be it in two-wheeler, four-wheeler, everywhere. Next please. Now, this is the type of bearing that you are using. Simply, what is the bearing? Bearing is a connection between a stationary part and a moving part. Many times in mechanical engineering, we need to connect a stationary part with a moving part. Imagine the wheel must rotate, but the seat on which I am sitting should not rotate. What will happen if that also starts rotating? Okay. You have a fan in your classroom. The fan must rotate, but the roof cannot. So how do you connect the fan to a roof? How do you connect it? Connecting something, two things which are stationary is relatively simple. You weld them, you join them, you bolt them, you glue them, do whatever you want. But one part is rotating, the other part is remaining stationary. How do you connect them? You have to. Whenever there is a connection between the stationary and the moving part, there must be a bearing in between. Okay? So, the axle in this case is going to remain stationary. The sprocket is going to rotate, so there must be a bearing in between. Next slide, please. Now, since I cannot analyze the entire cycle in a day, I have chosen what I can, because people say that I should not bite what I cannot chew. Is it not? I cannot bite the entire cycle. So what I thought was I will take a relatively small part and then try to really chew it. So I have taken up the valve tube. Do you know what a valve tube is? Okay. You are saying it. What is the purpose of a valve tube? Huh? What is the function that it should perform?
One side uniform manner.
Why is it called a valve tube?
It has only one side.
So one simple requirement of a valve tube is I should be able to pump in air, but air cannot come out. The first thing that I should achieve in a valve tube is I should be able to pump in air, but air should not come. Okay. First, let us see how this is achieved in a valve. Can somebody say how this is achieved in a valve tube? It is a one-way traffic. Air can enter into the valve. Okay. But air cannot come out. See, when you operate the pump, the air goes in. But the same air doesn't come out. How is it achieved? What? Let us see. Go back. Okay. Now, this is the essence, the central functional. This is the central functional part of a body. You have a rubber tube. You have a rubber tube and a honeycomb. Now, when these two are assembled together, go back, sir. Thank you. These two are assembled together, we have something like this. Now, the air is going to enter this way. The air is going to enter this way. Now, if you see, the air is going to come here and it is closed here, so the air can only exit through this particular hole. Now, if you see here, this is covered with a flexible, simple rubber tube. Since the air is exerting a lot of pressure, this rubber tube will expand and then let the air in. When I apply a pressure, what will happen? The rubber tube will expand at this part and then it will let the air in. The air will come inside this. This rubber tube will get bulky at this part and then it will let the air in. But when the same air tries to come out, what happens? When the same air tries to come out, it will come up and push in this direction. Now what happens? The rubber is getting more pressed into the hole, so it will not allow the air to come out. Okay. Please remember, it is a valve. What do you call it as a valve? It allows flow only in one direction. Okay. It is a valve because it allows flow only in one direction. How do you achieve it? By simply having, by having a flexible rubber tube and a hold nipple. The cost of the entire assembly, if you buy a fresh one, the cost will be something around 2 rupees. There is no moving parts. I can have various types of valves. There are various valves available. Probably you study in your design application lab. There is something called a reed valve. There are many valves available. But what is the beauty of this? The beauty of this is in its simplicity, in its economy. Right. Now we will go back and see what are the other things. Other things that need to be, the whole thing is a metallic arrangement. This needs to, a part of this needs to be part of the flexible rubber tube that I have. Why should I have this valve? This valve must be part of a rubber tube. Sir, can you go back to the first? Yes. So this is the whole assembly. Now if you see carefully, this is where the rubber comes, the rubber tube comes. This part is going to be inside the rubber tube. Normally, for you to appreciate, this entire assembly is part of the tube in the bicycle. I have removed the tube and then brought out this part. Is it okay? The rubber tube is going to be roughly somewhere here. So this part is inside the tube, this part is outside the tube. Now I have a nut here. When this nut is tightened, the rubber is pressed hard. There is no gap. When this nut is tightened, the rubber is pressed hard and there is no gap. So I cannot escape through the gap. See, another problem that I have is when I join a metal and a rubber, this joint should not give rise to some gaps. Right. Then what do I have? See, when I tighten the whole thing, this whole assembly should not rotate. This whole assembly, when I tighten this should not rotate. So what happens is, in this particular part, there is a slot like this. There is a slot like this. So, into the slot goes this flattened brass tube. So, these two flattened walls will prevent the rotation of that. So my entire wall which is protruding outside, it will not be rotating in its own axis. Then what happens? Can you please come back? Now this is the nipple part. This has two protrusions which will automatically align it and prevent the rotation of the nipple and ball tube assembly. Then the whole thing is kept in place by a thread. Now what I have to do is, I have provided provision as a designer. I have provided a provision to make this as an integral part of the tube. I have provided a provision to attach my pump to the other end. There is a thread here. So using this thread, I can attach the pump. So I have ensured that. Okay. So that completes the design of the valve tube. And why this is made up of brass? No, I am talking about material now. Why should I use a brass for this particular application? You have to think. You understand everything. See, all that I am trying to communicate is, I don't know how successful I am going to be, a lot of thinking has gone into deciding even the minute details of products. This is what I try to impress upon you, and then you must look for these details when you subsequently look at products. Because later on, if you become a design engineer, you have to think along these lines and then incorporate these features. Everything has a meaning. Why it is flattened? It has a requirement. It has a functional requirement. It fulfills a role. Similarly, why it is made up of brass? Why can't we make it steel? Brass is definitely 4 times costlier than mild steel, low carbon steel. See, the problem with steel is subjected to lot of corrosion. But my rim is made up of steel. The cycle rim is again made up of steel. There I have coated in some electroplating, and then I am using the rim. Then why can't I use the same material for the yes?
We are passing air inside, sir, so corrosion
Is it because of air that corrosion is taking place, or due to something else the corrosion is likely to be much more? Moisture, where is it? Is it high above the floor, or is it going to be on the road?
On the road.
அப்ப அங்க இல்லாத corrosive material. On the road we have so many sources of corrosion. Okay, corrosion is going to take place, but corrosion is going to be a problem for the rim also. When the rim is made up of mild carbon steel coated with some electroplating, why not my back?
Yes, sir. Apply some pressure over there.
See, in rim you don't have parts that are operated very frequently. I have many threaded parts. If these things corrode, okay, then the thread will be completely lost. It will not be usable again. And please remember, if this part is gone, if I cannot connect my pump to this, the whole tube is a waste. I have to replace the entire tube. The most vulnerable part of the tube is the valve. So that needs to be made up of a material which will not corrode and then lose its thread and accuracy and all that. So we don't mind using a material which is 4 times costlier, which is 4-5 times costlier than merchant. So I mean, again, all that I'm trying to impress upon you is there is some science behind, some scientific thinking behind, some reason behind many decisions taken regarding the design. Only when you analyze the existing product and then understand these nuances, you will be able to become a better designer. Can I go back to the next slide? Now, before I conclude, I have another. You have any doubts? Anything that you would like to discuss? Now, another. Cycle has very fascinating parts. Okay. Now, in fact, the first assignment that I am going to give you is on bicycle, not the entire analysis of bicycle. Now, I used to wonder many times when I pedal downhill. Okay, when I pedal downhill, I need not move the pedal. I can keep my legs just rested on the pedal. This in bicycling it is called coasting. C-O-A-S-T-I-N-G. Is it okay? I need not. Because otherwise, the vehicle is going to the bicycle is going to move at a very fast rate. If the pedal is going to rotate my leg, it is going to be very painful. I have talked about one-way arrangement. That is, what is the point of the valve tube? It will allow air in one direction. It will not allow the air to flow in other direction. Some sort of this valve is fitted here again in the pedals. That is, water will flow from the person pedaling the wheel will not be able to deliver back the power to the legs. Otherwise it will become very painful. Okay, when you go downhill, if the power, in fact there is excess power. There is no power input, but there is power output from the system to you. So then there must be only arrangement is provided. Can somebody name what is that
Central
arrangement?
hop, sir.
Yes?
Central hop.
Hello? Can you have the mic? What is that arrangement called?
Central hop, sir. In the axle there will be.
What is that mechanical element called? In the central half there is some arrangement. What is it called? No. Anyone? Yes? Somebody is telling that? It is free wheel. How does it work? Now, your first assignment, I told you in every class I have given assignment and the due date is the next week. Okay, this carries some weightage. I think I have showed you all that in the previous class. My first assignment is, how does a free wheel works? Is it okay? It is a mechanism which delivers power in one direction only. The assignment can be typed, it can be written, it can be with a lot of diagrams as possible. Okay. I mean, you need not, you can refer to textbooks if you want. Okay, but you can just Google and then get a lot of information. But the only condition is, it can be 1 to 2 pages, no more than 2 pages. Assignment should not be more than 2 pages. I will not be able to read. Okay, but please don't share your work. This I am going to be very, very serious. Okay, whatever you write, it should be written by you. It can even be a 1-page assignment. If you explain free will sufficiently, I will be happy, I will give you full marks. But if it is shared, if I find 2 identical assignments, both of them will lose marks. Please don't complain afterwards. I am going to be very strict because it is a matter of ethics. Okay, copying will be viewed as a biggest dishonesty in this department. Okay, you may have your own value system, but throw it away. Copying is unethical in this department. Is it okay? So don't share your assignments. Okay, you can submit to any of the faculty members. Every class has a designated faculty member. Aero students can submit to me. Mech A will submit to Shivakumar. Mech B will submit to Asrar. Mech C will submit to Munashir. Please make it a point, before you come for the next Thursday class, you must submit. Okay. Wait a minute, 1 more minute. Okay. This is for you to think and then come and answer in the next class. I have been holding this all along for the past 1 hour. Can somebody identify what this is? Spokes. Okay. Please study from me. You will appreciate it later when you study mechanics. A cycle wheel has many spokes. A cycle wheel has many spokes. Okay. I can also prove experimentally, at least at some point of time, the spokes, an individual spokes which is vertically downward, it takes a compressive load of roughly 250 newtons. It can be experimentally proved also. When you have about 1 kilonewton of load on the bicycle, 1 kilonewton of load. See, for force I am not supposed to use a unit kg. Force kg unit is newton. Okay, but since we know only in terms of kg, 1 kilonewton of force is roughly 100 kg. If 2 people sit in the bicycle, it amounts to 100 kg. That is 1000 newton. If a load of 1000 newton is acting on a wheel, okay, then in single spokes, because spokes will not take up any load. Of course, you will be able to analyze it better when you study engineering mechanics. The load is acting vertically downward. The horizontal members will not be able to take up any load because in the horizontal direction it cannot have a component. So at some point of time, roughly, the spokes which is vertical can take up, it takes up almost 250 newtons. Okay. But I trained with this is the spokes. Okay. The force I am applying will roughly be 10 Newton, 20 Newton. It bends. I'm just wondering how this can take up to, these are all facts. What I am applying now is maximum 20 Newton. I am not even exerting myself. You can very clearly see. I am not exerting myself. I am applying roughly 10 Newtons. But what comes there is 250 Newtons. How can this, it doesn't look very strong also. Is it not? Sorry. It again doesn't look very strong also. My question, which you should be able to think about and then answer, is how can this long, fragile looking spokes can take up to 250 newtons? Is it okay? Any doubts you have? This we will discuss at the beginning of the next class. Any doubts? Probably you should come prepared. Any doubts? Okay, have a good day. Bye.